So we have got the Wan 2.1 AI video models enabled to run natively in ComfyUI without a custom node installed. The latest ComfyUI update has integrated the Wan 2.1 models with native support. As you can see on the ComfyUI GitHub page, where there's the ComfyUI example section, we have Wan 2.1 models listed in here. The page shows the files you have to download in order to run this, which is the text encoder. And this is the UMT XXLFP8 version that goes into the model's text encoder subfolder, and the Wan 2.1 VAE files are going to the model's VAE subfolder for the video models. The diffusion models, of course, go into the diffuser's diffusion models folder, very self-explanatory, where you'll find various AI video model files you can download. For example, we have the text-to-video for 1.3 billion parameters and also the 14 billion parameter models. Two types of sizes are also going to save that in the diffusion model subfolder, and that is located in the ComfyUI org Hugging Face. This is the repackaged files of the model weights where Comfy has created these repositories. And when you click through to the split files here, you will have all the lists of the 4 AI model files. And that is according to the model subfolders where they are going to be stored. So, based on those file names and the folder names, you save that in your ComfyUI models subfolder, then that will be good to go. But there's something that we have to mention, which is the diffusion model files, where it uses both image to video and also text to video, two types of models. We have resolutions for 480p and 720p for image to video. And all of these files, as you can see, are in the BF16 type, which is not FP or FP8. This is BF16, and it is able to run without Triton and the Sega attentions. You can just run that natively in ComfyUI using the native nodes without configurations or any additional options. Now we have the text encoder, which gives you the FP16 or the FP8 versions of this text encoder, whichever one you prefer to use. But of course, for the GPU below 16 GB, I suggest using the FP8 for ideal performance. Otherwise, you will be waiting for an even longer time for the video generations each time. For the clip visions, this is the Clip Visions Edge. Now, I have tried the other one where it is located for the clip visions for going through your input image for image to video generation type, and I have also tried the Clip VHFP16 that was coming from the previous IP adapter that we had in Stable Diffusion, and this one is also able to work. Sometimes it will have some incomplete noise. You see that in the video generation result. So it's better to just spend 2 more gigabytes of storage space to download the Clip Vision Edge for the Wan 2.1 if you want to run that in native ComfyUI nodes, because this one is going to be able to run and process without some pixelated noise or incomplete steps. You will see some noise showing up in the video generation results. So I would suggest not to use the Clip VET HFP16, which was coming from the IP adapter. So use whichever is listed as recommended in the updates of the ComfyUI GitHub repositories. That's ideally the method to go. Scrolling down the page, as you can see, we have the text to video and also the image to video. Now, image to video has some differences. We have the 480p resolution, which is a smaller size for your video dimensions, and the model dataset training as well. And this one is going to be easier for lower-end GPUs to run instead of having the 720p resolution, which of course has better motion and nicer performance on video generation but requires a larger size of VRAM to run. So for most consumer PCs, I don't think we will be able to or should use the 720p for normal usage. For servers, of course, you can use that. But even in my case, when I use server GPUs to run AI videos, I was just using the full model weights instead of having the repackaged saved tensor files. Therefore, I think most people will focus on the 480p resolution. These files for image to video are also in the Hugging Face repositories. You click to the diffusion model and you have all 4 files, and the 480p, which is in the first row in this table, you can download this one. But of course, you see the file size is 32 gigabytes, which is much larger than what I had in my previous videos that talked about the repackaged model files from KJ, which were about below 20 gigabytes. So you have to measure that. If you have more file storage, you can download both KJ and also the ComfyUI official repackaged files. Or if you want to run it natively, just run ComfyUI disk copy or other ways you ran that in the previous videos using keyGenodes to create videos. So in this video, I am going to show and run how to use the native nodes like this one. I have combined two video generations. One is the image to video, and at this workflow, the bottom part is the text to video, which, as you can see, all the custom nodes or the nodes are coming from the native ComfyUI. Before running this, you have to update your ComfyUI first, get your ComfyUI to the latest version, which is 0.3.15. This is going to be the latest update of your ComfyUI version because there's some merge and updates coding for the latest one. Also, they have mentioned the same content in comfy.org blog website post where it shows the latest post introducing the Wan 2.1 as well as each model weight, what it is doing, and what resolution is also ideally running with 480p, as it also mentions 5 seconds of 480p video on NVIDIA RTX 4090 takes about 4 minutes without quantizations. So, this is pretty nice for lots of people who are using 4090s. As I know in our Patreon groups, a lot of us are using that as well, and also some are using the new NVIDIA 50 series. We have a guy using 5090. Actually, two people have bought the early stage founder edition of that, so that's good news for people with that high-end GPU. And also, the multitask Wan 2.1, as I have mentioned in the previous videos, is not only generating text to video or image to video, but is also doing video editing and video to audio and text to image. But I see that so far, this current repackaged files in Hugging Face using this model and the current updated ComfyUI with the nodes in here, the native nodes, it doesn't do or have the way for doing video editing and video to audio yet. I'm sure that will be something maybe updated later, just maybe, because who knows, we are not the insider developers of the team, we have to wait for the news update on that. But just going through the latest blog post here, we got 4 files that need to be downloaded: text encoder, diffusion model, VAE, and clip visions. And with these 4 sections of AI models, we are able to do both features at this moment: text to video and image to video. Here are showing the examples, which you see are 720p workflows for the 14 billion parameter AI models, generating pretty good results just by using local or open source AI models. They are able to generate such things, and the 480p, of course, is lower resolution. We have to see the result like this compare. Of course, for the higher resolution, 720pt is two different things. But then the motions and generated results are also able to create pretty much dynamic motions for each object in the video. But for the detailness and video resolution, of course, using the higher res, you will get a better result for your videos. And one of the good things about the Wan 2.1 is that it has the 1.3 billion parameter size text to video model, and I am just downloading this one for handling text to video only because this is quite good enough for generating text to video results. It's just a 14 billion size compared. It is the same features. Everything architecture of the AI models is the same. Just only the dataset size matters, which is the difference between the text to video 14 billion and the text to video 1.3 billion, which is just only the data size that matters. And the difference is only that. But if you have a good text prompt to instruct using the 1.3b, there are no issues generating videos. So let's check out the ComfyUI first. We have 2 groups here, one for handling image to video and the bottom one which is handling the text to video. I have also added the create sound effect, which is going to be using the audio, and I have X doing the output of the audios connected to the video combine. Pretty self-explanatory in here. And we have the notes group here. Actually, I did manage the notes group and convert the different notes, like this spaghetti messy thing, and I just grouped this into converting into a group of notes, so therefore I am able to just have a simple one block of content on this diagram, easier to manage and easier to read. It's more modular using this way, and as well as the upscale, it is the same as my previous upscaler using the SDXL or Flux for doing the ultimate SD upscale. When we back to convert to notes, you see all the connections and the formulas doing the size in here, so I don't want to be too much spaghetti going on, so therefore I convert the groups to one single note in here, and this is for SDXL this time. I want to try that because it's loading faster. We don't need to use Flux that heavy to load each image frame and upscale that in here. So, do what we need, and that is enough. And back to the image loader, I have again the file path, I always like to use this image from path, easier to manage for myself if I don't need to do manual masking using the load image nodes. And in this case, we just need to input the image files, transfer that to the pixel. We got a new node in ComfyUI native nodes, which is called Wan 2.1 video. This is the node that we receive the image start, image frames, and also the clip visions output, which we have mentioned downloading the clip visions. So we need that. We connect the VAE as well and use the conditioning positive negative to control our AI generated motions. And also, we got the sampler. This is just a normal case sampler, and as you can see right here, some people have talked about this before, using the DPMPP2M, which is a good sign, a good scheduler method for generating videos. But then, when I saw in the default workflow in Comfy that Comfy has published this one, it is using the UniPC. As you can see in this field, you can take a look at this in the official ComfyUI blog post. It's also using the UniPC, and the scheduler is simple, which I have found. Also, the Wan 2.1, you can check the GitHub page of Wan 2.1 where it has the official generation code. The inferencing of this video model, when you click to the generate PY, you will see such things that call the sampler. It shows that by default, using the sampler method is using the UniPC, and the choice of having in the sampling method is UniPC and DPM++. So therefore, both of these sampler methods work, but by default, they prefer using the UniPC to run this AI model, which I think is why Comfy is showing the showcase in the official page in ComfyUI using the UniPC, and the scheduler using Simple, which is also. You can check that out from here as well in the code. It tells you some hints about what you need to do, what you need to input to do the inferencing with this AI model. Even the same concept in ComfyUI, you have the options for that, such as the UniPC and also the DPM in here. So yeah, whichever way you do it works as well. But let's try the default inferencing because this is what they prefer in the Wan 2.1 official GitHub page. And we will generate 2 results on each generate method, and we will see how that looks like before we do the sound effect and upscale. Okay, so I have to generate results here. At the first time I generate the image to video, and I have this image like cinematic scenes of alien invasions where this character looks like Wonder Woman or Superwoman looks-alike costume laying down because it's lost in the battle, and the alien is trying to step over the superhero. And then I have tried this with this text prompt doing a cinematic scene of alien invasions in the city collapse and burning, and then doing the actions which I have described, the aliens in the foreground trying to step on the superwoman on the ground, which did something that is following the prompt. Here, of course, is kind of very low resolution. That's why you will see some large pixels on the edge of the alien. But then you see the actions are able to follow what I want to do in here. And for the resolutions, we configure with the initial loading of the image where you have a lot of ways to do that. You can do image resize, and then I am using the aspect ratios in here, standardized, to what kind of width and height are you setting for. And I'm just using the very small size aspect ratios here because this AI model that I am using is 480p, so therefore there's no point to use high resolution to generate the videos. And as you can see right here, I have used the applied TCache. So I have tried other custom nodes that use the first block cache and also the other custom nodes using TCache, but it doesn't work. Only this one, the ComfyUI patch 2 custom nodes package. Within that custom nodes package, there are 2 nodes called the DT forward overrider and then override that data for applying TCache patch, which are able to go through this generation. And yes, it is faster for the generation times, where I have got the generate result here after this text to video, which in this group, text to video, I am generating the angel scenes. Well, it is kind of smooth with just text to video where I don't have any other advanced referencing or image referencing. I am just using the 1.3 billion size parameters for text to video. And also, I have applied the TCache patch to custom nodes, enable to render a little bit faster, also 20% as well in here, optimizing the speed of generation. And go to command prompts here. Let's check. I have this one, the last generation, which is the text to video. I'm using 40 steps to generate 81 frames. This is right here. You see the empty latent videos. I am using 81 frames, which is standardized for what it has in this AI video model. And then we use that, of course, having the frame interpolations allow that to boost up to 162 frames in the final generate result. We got 2 minutes and 58 seconds to generate that inferencing time. And before that, I have the 20 steps. This is the image to video that I showed, the alien invasion scenes, which I have 7 minutes 34 seconds to spend on the generation times with that. Because I was using the normal model data to pass through the TCache patch to generate without using the Trident and the Sega attention method to generate in this pipeline. Because that one is it's okay for the Linux OS, but still, even though I have tried it on Windows, although I have installed that properly in Windows, sometimes it's not working quite good for the Windows OS. So therefore, using the Trident and the Sega attentions, I prefer using that in Linux OS. That is better. It's just, we don't have to explain that because the Linux by default comes with the Trident libraries. So therefore, we got this to generate result here. And if you want to do the sound effect and upscale, of course, we have to enable that. In the group, by that I always like to use for managing groups. First, we go to the create sound effect, jump to this group, and we have the drop-down menu to set the receive video result. So in here, I got the text to video and image to video generated result where we pass those image frames. For example, I have the image to video result here, and it will be processing for the sound effect using Audios, as you can see right here. Audio's model loader selecting the VAE as well. Everything is set in here, and then you can do the prompt for how that sounds like. But then sometimes I just leave this to empty and let the AI decide that for me, have a random seed or something to generate that as well. If you want to be more specific about what kind of sound for the sound effect, you can most likely use the same text prompt in the generation. Put that into the prompts here. You are able to do pretty much matching with the styles for the sound. And then next one is the upscaler, which I have grouped that bunch of notes into one group, notes, they call that. This is pretty handy, a nice one to manage different notes into one single group note. For you to just reduce more space on your diagram in here, where you have a lot of options to choose from. But so far, I have predefined everything in here. We don't need to touch anything. Just have to choose your right upscaler models, and you are ready to go. And also, connect the sound effect in here. So this output image output video will have the sound effect embedded into the audio track as well. So let's check out if I want to do the alien scenes. Although this is kind of pixelated at the end here, kind of morphing, but still, okay, we can give it a try and see how that looks like. Should be the angels getting a better result in here. So we gotta bypass the text to video group first, and we run it one more time with the image to video result. Send it to the groups here. Okay, so we got the generate result for the second time when it runs. I have set to fix seed numbers, and then we have the audios generated, and also having the upscaling working on its progress. While we are waiting and see the result for the second generation using the image to video for this image, and we have this scene. This time looks better than the first time I have tried to generate. So for image to video and even text to video, it's just like gambling. We have to try with different seed numbers, which you can set on the sampler here, right here. Right now, I have set to fix seed numbers. But then, if you generate that and don't like that motion or that scene, how that looks, you might have to set the other seed numbers and try with another generation. So therefore, it's unable to control how that looks, how that alien, for example here, walks or steps using that motion. But then, this time, pretty lucky. And the second generate time has the explosion behind and allows the alien to crawl and step on the superhero's body. Like this motion that I want in the text prompt as well, I have described that. So this path to the upscalers is, okay, try to see how that looks in the upscaling result. But then this model has some problems which when it's at the end of the frames, you see some still lighting having problems for the alien's chest in this part. It's even going too dark in this part, not sure. Might be we can do other steps number or the CFG settings, we can test that. Well, this is just the first day it integrated into ComfyUI using native nodes. A lot of stuff can be tested. A lot of things can be changed by time. It's not the absolute answer, a textbook answer for how you connect it, generate the image to video, and as well as the text to video. But then, for the text to video, this result looks pretty nice for what I have in the text prompt, and I think I will also upscale this one and see how that looks. And in the meanwhile, I have other examples that I have generated before when testing this workflow, how this custom node and the native nodes connected, And I have one with the text to video, which is a Korean-style dance animation. Just a 2-second one I was trying to do, and then doing another upscale with this, and also a second attempt of the same prompt with other seed numbers, and we have this generation. And then I did the third attempt, which gets a little bit better for more Korean styles, K-pop dance. And then I use image to video, which I have done with some image like this and also some creepy things and some motions for the elf and also for the demon like this. And this one actually has a sound effect. So I will show the upscaled example from the 2 generated demos at the end. And I will see you in the next one. Have a nice day. See ya.